Got it. Let me share my screen. All right. Hey, so can everybody see my slides?
Yep.
All right. So I gave a longer kind of two-part training. My name is, for folks who don't know me, my name is Brooks. I'm a lead developer at Insulet Corporation. We're a medical device company in Acton. So this is a very abbreviated version of part one of some training I gave to our devs about bringing Jest into our front end, into our JavaScript code base. And I'll say that having been part of an enterprise front end project without test classes, like I'll never, ever do it again, right? Stuff's breaking all over the place. Nobody knows what caused it. UAT is raining bugs, and Jest goes a long ways to solving those problems. So what is it, right? So Jest, it's a JavaScript testing framework. It's open source. It's developed by Facebook, Meta, whatever we want to call it now. And I mean, I think everybody here, right? We know why it's important to test our code. And you know, when I talk a lot about at work, it lets us, especially when we're talking about our Lightning Web Components, right, to really shift that QA process to the left as far as we can. So, you know what I don't want BAs to find anything. I don't want QA testers to find anything. I want, you know, the devs, the engineers to really own the quality. And that's really, I think it's tough to do if you don't have a unit testing framework for all your Lightning Web Components. So Jest helps us solve that. What I talk about a little too, so Jest is, especially I feel like for a lot of people in the Salesforce industry, it's a little because Jest is about unit testing versus, you know, end-to-end or integration testing. And I certainly kind of approach this in my career for all the same ways, is kind of thinking that all, you know, your Apex tests, I wrote them all as integration tests, right? We're going to insert content, you know, this massive test setup. But what we really want with Jest, right, is, you know what I mean? So I would say like Jest is, it's Node. It runs on your machine. Jest doesn't even know Salesforce exists, right? So at no point is Jest making sure a contact was added to the database or that somebody's last name was updated successfully. Jest is fast and reliable, and it's going to verify that that function, that method, I should say, you wrote in your Lightning Web Component does what you thought it should do, that what you think renders in your HTML renders when you think it should. But it is completely cut off and separate from Salesforce. And so any questions? I should pause between slides before we get into the code, but any questions at all about that piece? All right. So Jest real quick. So if you've never set up Jest, so it's a Node.js package. So a couple things is you do have to have Node on your machine. And if you're not sure, right, you just, you know, Node --v, well, in the terminal will let you know. But in Node, if anybody's not familiar, right, is it's a local JavaScript runtime. Basically, got his name. Somebody much smarter than me took the Chrome V8 engine out of Chrome and lets you run JavaScript on your machine instead of inside of a browser. So this is work specific, but I think it's worth calling out. If you have OneDrive at work, or my experience is OneDrive does not play well with Node modules. So if you're doing any kind of repo that's in source format, right? Because you have to be in source format to use Node. I find that OneDrive will always bork my Node modules, right? Just keep it out of that path. Also, just house cleaning, like don't Node modules they shouldn't go in version control. And you know, actual, like if you just set up a SFDX project from the command line, it will, I think, add Node modules to your git ignore file automatically. I always need to install Jest separately, and these are just housekeeping. And also for like Jest tests, they run on your machine. They don't run in so you're never deploying your Jest tests to a Salesforce org. They're running on your machine. They need to be checked into your version control, obviously, but they actually in a project, they need to be on your force ignore file. If you try to deploy a Jest test to an org, you'll just get an error. All right, so that's just kind of real quick down and dirty what Jest is, what we use it for. There's not any questions. I'll hop right into the code and we'll just look at a couple really simple examples. All right, so first I just want to show real quick. Let me go to my package.json. If you're not familiar with it, you're going to have, when you create an SFDX project, you're going to have a package.json. This is just really a node script. You can see, you've got your Jest installed, and I use IntelliJ with Illuminated Cloud. So I could either, I have a lot of ways I could run my.
I'm not saying
Brooks,
you're.
yeah, you're not sharing anything, Brooks.
Oh, really?
Yeah,
You
we're
guys can
still
see-
looking at your slides.
I must have just, let me find the meeting controls.
Yeah, you may just be sharing the.
Yeah, I bet I'm just
application
sharing,
To the desktop.
right. I'm going to stop sharing and then reshare again real fast. Thanks for. All right. Everybody can see my package JSON. Okay. So a lot of ways you can run them, and I'll show them, but right, you could, for me, like I could just click here, run tests, run it from my command line. Some of the things that can be really useful though, you get your code coverage, just like we do with Apex. To me, what I want to highlight is test unit watch. When I discovered this with Node and doing some MERN Express stuff, this was like the life-changing thing for me. Basically now Node is watching your Git directory, and when things change, it just starts running the tests on the appropriate, Lightning Web Component. So it's a great way to just, you're changing your JavaScript file, Node just starts running the relevant tests. So I really love it. But let's just do our first really simple test. And then we'll try to do like another really simple one just with an actual DOM in it. But our first one, right, and this is right out of Trailhead, right? We just have this simple, got a function, right? Takes two numbers, returns the sum, all it is. So again, I use IntelliJ with Illuminated Cloud. So it does, if you're using Visual Studio Code, I think you have to do this a little more manually. But you're just going to go to your LWC directory. In this case, it's my my JS utils is the name of that one. I'm going to do a new Lightning Web Component JavaScript test file. It's just going to create that for me automatically. And again, this is this is an Illuminated Cloud feature. And for this one, because we don't actually have like a DOM, I don't need create element. We'll show that one in our next one. For this, we're just going to test. So what it's going to look like, we actually have to import our.
I don't use that card, so. No, I don't.
So we have to import that in, right? The actual JavaScript file that we're going to test.
I haven't gone, like.
Oh, but I have my own.
And then all of our Jest tests.
And I
always
have a bill
begin-
from what?
Someone's mic is on.
like-
Someone's mic is on. Dan, iPad, Air, your mic is off.
Like when I go to my, I don't pay for a physical. So I'm a physical.
There we go. So Jest test. So first we have to start with a bit of setup. So your entire test is going to be housed inside this describe block, which is essentially what you're going to use, like name your test suites. All right, we'll just call it test utils. And for this one, then all we really have to do, right, we're just going to give it a good old JavaScript callback function. And sorry, my ESLint doesn't like it because I left a space there. My red squiggly would keep staring at me until I fixed it, so I had to stop. So we're going to do const, we're going to say const result is going to equal get sum 2. And then what we do, it just provides what they call matchers. And there's a lot of matchers out there. So really worth taking a look at the actual Jest docs to figure out what to use. But what we're going to say is, so whatever result evaluated to, we're going to do expect. And expect, for if you're used to Apex, that's the equivalent of system data. That's the equivalent of system assert. Right? And you know what? I missed a step in here. So we're going to say, I'm going to copy and paste that out. So we need our it block. We're going to say it. We'll say should return a sum. So inside our describe test suite, we then have our individual tests are going to start with you can use it or test here. So it is just an alias for test, but this would be the equivalent of your test method in Apex now is the it block. I'm going to put that code I deleted back in before, right? We're just going to see what get sum evaluates to and store that in a variable called result. Expect is the equivalent. That's our assertion, right? That's our system.assert statement. So I'm going to say expect result, or not rest, result. And then for my matcher, I'm just going to use 2b4. And so this would be exactly the same thing as, test method. We're going to name our method should return a sum, set it up, system assert result 4. Exact same thing. Jest, we're going to run that. And you're going to get your results back in your terminal. Which lately have been running a little slow on my work machine. I don't know why. So usually just are really fast. Lately mine seem to be running slow.
Do you know if the Jest runtime is resident in memory or it does code start every time?
You know what? That's a good question. I don't know. I don't know. But that's what we'll get back, right? And this is if we're not running it with coverage or we don't get anything wrong, right? It's going to just get the check blocks and that our tests have passed. We could also run code coverage and it would look, just kind of like it does in Visual Studio Code or IntelliJ with the green and red lines on your JavaScript. Bing, if we have time, I can do a slightly more real world one with an actual Lightning Web Component that has a DOM.
Right.
Okay.
Yeah, sure. Let's do that. Let's probably take another 5 minutes. That's okay. We're pretty flexible.
All right. So if we do another one, I'll show like events, and because a lot of your tests are actually going to cover events. So I have this again. It's our Lightning Web Component called DOM Basics. And right, that's all it is, right? We've got an H1 with a hello, and then it's bound to a text value to this public property in our JavaScript file. So if we were going to test this, same thing. We're going to create our new test file. I just said I point out that's going to create a directory right inside subdirectory in that LWC file with the test. Now this is where you'll need the import create element, and that's a Salesforce thing. So again, for me, like Illuminated Cloud just adds that in for me automatically. I'm not sure about Visual Studio Code, but any testing you're doing with the DOM, you're going to need that, and it's a Salesforce. We also need to import our actual web component. Right? So we're going to import DOM Basics. DOM Basics. All right. Then, exactly like before, we're going to just get our quick describe block. Okay. DOM Basics test suite. Give it a callback function. And when we're doing Jest tests with the DOM, you either kind of have to do a little bit of setup or tear down with each test. So for this, we're going to do after each. And what we're going to do is we're checking to see if there's anything, if there's a, if the, well, document.body.first child, right? So we're looking to see if there's actually, have we actually appended anything to the DOM? And when I say the DOM, I should go, it's part of the Jest framework is the JS DOM, right? There's no actual browser running here. This is a mock DOM that Jest is creating for us automatically. And if there is something there, we're going to do document.body.remove child, document.body first child. And that's all that. It's like the DOM. That way we don't have, if we had, 5, 6, 10 different test functions going on in here, right? We don't want to have artifacts from our previous test in the DOM, right? So it's the way of just kind of clearing out any previous testing artifacts and starting over with a clean slate every single time. So if we wanted to, let's say so what we expect, right? If this is my team and we were really doing this, I'd say, hey, you know what we want? We want to make sure when this markup, when this LWC loads, right, that what we expect is on the screen is going to be there. So we'll say it should render state, callback, put my friends there. And now what we actually have to do for our setup is we have to create the element. So const element, create element. And now we're going to use that create element that Salesforce gave us. And I always just name it the same as what it actually shows up on the DOM. So DOM basics. And then last thing is we have an options object. And we use this to pass in our actual web component, right? So the actual markup now gets loaded into that create element. So we've imported it up here. And we've created this element that we're about to stick on the DOM. And we're saying, hey, name it this and pass this markup into it. And then what we've got to do is document. So if you've written a lot of just vanilla JS in your life outside of any particular framework, right, this should look probably pretty familiar. Body.append child element, right? We're just no template query selectors. We're just back to putting stuff on the DOM document. So now we've taken that element, we've created it through the Salesforce create element function, and we have put it on the DOM. So the next thing we need to do, and again, I said this is just should be, real familiar if you've written a lot of just vanilla JavaScript, is we need to select that header element. So I'm going to say const header equals element dot shadow. So this is a little different right now because we do have the shadow root to deal with. We're going to do shadow root dot query selector. And just like any selector in JavaScript, we can select at this point, it's an H, we could select by the tag name, H1, we could select by class, you could select by, lightning, etc. So there's lots of ways you could select. In this case, because it's an H1 and it's the only one on the DOM, I'm just going to grab that. So now we have our header, and what we expect is we make our assertion header.text content header.text content. And I'm gonna, maybe we'll have this one fail first, just so we see what that looks like. Now we're going to run our test suite. And like I said, this will fail, but I think Jest actually gives really helpful failure messages. And I would say these are by far the two easiest ones. Events, all the real world stuff we're doing gets you have to do a little more some asynchronous steps, right? Because if you're updating the DOM, it happens asynchronously. Working with mocking your Apex is is also, I mean, that's probably could be a 30, 45-minute session about how do you mock the wire service? How do you mock imperative apex? Because you're going to have to start making, you know, a JSON, you know, contacts.json and using Jest to, you know, if you had 10 contacts and you expect 10 cards to render on the screen, you're going to have to pass in a JSON file. But so, okay, so now we get this one failed, right? And like I said, I think Jest gives very, very helpful failure messages, right? We expected hello world and we got back hello Brooks. Wait a minute, we'll just change that. And that should, we got a little red squiggly there, tell us that one passed. And I'll run it with code coverage also, just so we can see what that looks like when we do a Jest code coverage. But Jest has, I mean, a bewildering number of matchers you can use, right? You know, should be truthy, you know, because sometimes you have to mock functions, you know, expect to have been called, right? There's tons of matchers out there. It goes way, way deeper than, you know, system assert. And I still failed because I think we'll call it good and we'll accept the failure, right? Because I didn't uppercase my H. But we'll let the code coverage results load up, show what those look like. For whatever reason, maybe it's because it failed. It's not loading all my maybe it's because I had one test and it failed and didn't load up my coverage. But yeah, I know we've got other speakers, so that is all I'll do. Just real simple intro to Jest. If nobody has, happy to answer any questions if anybody has any.
So do you feel, you know, when you create Jest tests around LWC is like there is a level of sort of boilerplate stuff you have to do for realistic testing?
Yeah, right. You are, especially with your setup teardown, right? I always say, I feel like it's kind of this devil's bargain, right? I can either kind of do this audit, kind of like script my teardown one time, and then I do my setup like that. And there is also a fair amount of boilerplate. You know, if we were going to, I'll just copy and paste it from somewhere else.
Right.
But if we were gonna actually we were gonna say change that public property, right, where name was, right? There's more boilerplate because now it's that happens asynchronously in the JS DOM, right? So you kind of have to flush a promise through the system, clear out the microtask queue, and then you could actually, because if we went and changed that public property right now and ran the test would fail. So yeah, absolutely. There's a good amount of boilerplate with Jest.
Yeah. Makes sense. Thank you. I do want to say this may look like it's not easy to do, but I do feel it's pretty important to learn because I've heard from kind of different sources that Salesforce is considering, you know, doing some sort of test coverage requirement for Lightning components, you know, or like the Apex test classes.
The other thing I'll throw out there too is I think Node is starting to, because this is Node. I think Node is starting to have more and more uses in the industry. I was scripting a sandbox refresh thing with Node this morning, right, and manipulating the Salesforce CLI, running anonymous Apex, because all of these modern projects, right, you've got, I mean, I love it, right? I've got a package.json. I can npm install, you know, whatever I want. So I think Node in general is going to become a tool that will be more very useful in the industry.
Right. Great.
I have one quick question about the unit test watch that you mentioned in the project JSON.
Uh-huh.
Does that when does that actually run? Is it like when you save it?
So I don't know about Visual Studio Code for IntelliJ. I don't actually have to like hit Control S. So it just, when Git starts detecting changes, it starts running.
And then it runs the whole test?
No, I mean, it runs the tests that are relevant to that web component. So it won't run, right? If you had this
Okay.
giant JavaScript code base, it's not going to run, all 100 of your tests because you changed one web component.
Okay. Thank you.
Brooks, that directly underscore tests underscore, is this your personal preference, or that's just how
No,
it has to
great
be?
question. Yeah, the dunder tests, that's what it has to be named. Sorry,
Thank you.
I forgot to call that out. I'm so used to just letting my IDE do it for me. I forgot that. Yeah, that it must be named that. All right. Well, I'll stop sharing my screen.
Thank you, Brooks. All right. Next up, Brock.
Yeah, thank you, Brooks. That was really interesting. So I'm just gonna talk through a few miscellaneous like DevOps tips and tricks. So let me just get started. The first one, DevOps starts with Git. You may be familiar with Git flow. I'm just kind of zooming in on the develop and feature branches, which Git flow is an effective branching strategy for Salesforce release management. So this is kind of like, how do we implement release management when we're using Git flow as our branching strategy? So the development process that I like to follow is that, every time a commit is pushed to a develop branch, we'll deploy to a dev sandbox or dev int sandbox or dev integration sandbox. And you assign the developer that actually worked on the story to smoke test their own work in the dev integration sandbox to prove that when it's integrated with everyone else's changes, that it still works as expected. And their job is to smoke test and either pass the smoke testing by the end of the day or revert their change and reattempt the next day. They work by branching off of develop, creating a feature branch. Typically want the branch name to include the ID of the story in Jira or Azure DevOps. And, I've actually had a good amount of success working with sandboxes that are cloned from our QA environment so that all the data gets copied over rather than working out of scratch orgs. Because what I found with scratch orgs, the hardest thing to do is to build in scripts that automate staging the environment with data that you can use to kind of run tests and actually prove out that the application is working as expected. So they work in their private dev sandbox, submit a pull request, assuming that it passes smoke testing by the end of the day. At the start of each day, your QA manager approves a deployment to your dev QA sandbox. And the purpose of having this daily process is to ensure that you have only like a stable code base in that sandbox. It's not frequently changing while a QA tester is running through their test scripts, and that the dev has at least gone through the motions of making sure that their work appears to be working in an integrated environment. And I found this to be an effective way to manage the develop branch and ensure quality. And then the private sandboxes are then cloned from the dev QA dev sandbox, and they include all the data that the QA testers created when staging their tests. So the next thing I wanted to talk about, just a really simple solution to solving a lot of the gaps in the metadata API. So some setup objects are not supported by the metadata API, but can be inserted in Apex. And some deployment steps involve manipulating data or performing steps that can only be scripted in Apex. So what I like to do is give developers folders to drop Apex scripts in, and then run those automatically pre and post deployment, allowing them to solve deployment challenges independently. So it just that shows how to do this in PowerShell. So essentially, you have a script that runs pre-deployment, and it just loads up my scripts Apex pre-deployment folder and runs all of the Apex scripts in sequence. And then, we do the same thing post-deployment. Run all the scripts in the post-deployment folder. And now, like if you need to potentially like assign a permission, create a user that can be used to like run a registration handler, assign a permission set to the CI/CD user. There's all kinds of things that you can solve and make your deployment automation more robust than it would be if you just relied on the metadata API.
Right. Do you have some examples, some of the things that are not really supported well by metadata API, but you can handle that in Apex?
Yeah, so we're using OpenID Connect with auth providers to do single sign-on into Salesforce.
Yeah.
And your auth provider has to define a user that is used to run the registration handler. So when someone signs in and it executes just-in-time provisioning,
Yep.
it runs with the permissions of a user that you specify. So we actually created a pre-deployment Apex script that creates a user and assigns them a permission set so that they can run the registration handler. So we've totally automated the process of creating that user that runs the registration handler.
That makes sense.
Okay, so my last one here is just automating the process of deleting flows. I'm sure you've all had pains trying to include flows in your destructive changes XML file. So I made a list of the blockers that I've run into and how I solved them. So one is flow interviews from paused flows or scheduled paths prevent deletion. So if someone's paused the flow, you can't delete it. And the way I solved this is I put an Apex script. I created an Apex script, and then I created a PowerShell script that can actually inject the flow API name into the Apex script and then run the script. And so the script can query any related flow interviews and delete them. I'll show you how that works in a moment. Another common blocker is that the flow cannot be deleted unless there are no active versions. So if you know how the flow definition meta file works, you can deploy a file that will deactivate all versions of the flow, will deactivate the active version of the flow. So I just include that as a template, and then my PowerShell script renames it, deploys it. And then the metadata API does not support deleting the flow as a whole. So if you go into the UI and there are no active versions, you can just click delete on the flow. But from the metadata API's perspective, you actually have to delete each individual flow version. So, but what you can do is query for those flow versions, loop through and delete each flow version. I did it kind of a lazy, non-bulkified way for this demo, but the optimal way would actually be to loop through and build a package.xml file, create that XML file in PowerShell and then deploy it as a destructive change. But you'll see I'm calling for source delete in a loop for the purposes of the demo. And then the one problem that I could not solve, and I think it's probably a good thing that I couldn't solve it, is you can't delete the flow if it's referenced. So, if you have the flow in a Flexi page, this process won't allow you to automate deleting the flow. I have a link to a repo where all of this code that I'm about to show you is. So first thing I want to do is go into my org and debug this flow and create a few paused flow interviews. So now we have, at least one paused flow interview. So, if I was to try and delete this flow, it would prevent me from doing so. And if you take a look at my script that I'm about to run, as I mentioned, the first thing it does, it finds my Apex script and it replaces this variable with the flow label that I passed to this PowerShell script, creates a new file and injects that content into the file, and then it executes the script. So this Apex script will be updated to run and delete the flow with the name that I passed to the script. The next thing that it will do is it will delete that Apex script out. The template will still be there, but the temporary Apex script will not. Then it will take my flow definition meta file that I have in here somewhere. So this is the flow definition file that you can use to deactivate the active version of the flow by setting active version number to 0. So we'll rename this file and deploy it. That will deactivate the flow. And then lastly, it queries the flow object, and then we loop through and run force source delete using the flow API name and the dash and the version number. So to delete it, you need to pass a name of like AppSuite Wizard -1, AppSuite Wizard -2, whatever the version numbers are. So this will loop through and delete all versions of the flow. To actually include this in a live project, I would instead just construct an XML body and insert that into an destructive changes.xml file and run one deployment to delete all the flows. But I just wanted to get this together for the demo. So I'm going to now just kind of take you to my flow here. You can see there's an active version. I showed you my my paused flow. So now I'm running the script. I have to pass the label and the API name. And it will do everything in sequence. Lastly, it's deleting the flow. All right, so it's deleted. So now you can see no more flow.
Nice.
All right. So any questions about any of these topics?
Brock, can I have your slide deck?
Yeah, I was planning to share it out.
Okay, great.
So I'll send it to you.
Yeah, thank you. I'll get it.
It has links to Jest and repos for all the code that I showed.
Right.
And I like to end by introducing myself. My name's Brock. I'm a CTA. I implement Salesforce for the federal government. And I just gave you some links in case you want to follow me on Twitter or read my blog, which I'm going to be updating again soon. Thank you.
Thank you, Brock. This is a lot of fun. I want to say that we probably should do some sessions about shell script. Brock is using a PowerShell, but if you do Bash script or Z shell, that's all very important, especially if you're kind of doing a lot of CI setup on your own. This is a super useful tool. All right. Oh, we got Marty here. Hey, Marty.
What's up, Bing? Nice Prezo Brock.
Thank
Yeah,
you.
happy to take over. I think I'm at the last presenter, Bing.
Yes. Yep.
Right. This will be super light. Nice way to cap off the evening. But I'm going to dig in here. I'm curious how many people have seen the little message that says, please try out record trigger flows in Salesforce. Raise your hand, post an emoji. If you don't like it, you can post a thumbs down emoji. That's cool too. All right. So we can, this is just a quick intro. I got to dig into this a little bit. Personally, kind of excited for this new feature to come alive. And I think for the developer crew here, there will be mostly, I think, just a quick view, and then we can happy to take any questions or discuss the implications. But anyway, my name is Marty. I am the Director of Business Systems at Drift, which covers Salesforce, NetSuite, our integration platforms, and our data engineering, data pipelines going into Snowflake as well. Lots of fun stuff. Salesforce is a big piece of that. And the agenda for today, just really three things. I want to cover record trigger flows, what they are, how to migrate from workflow rules and process builder, some of the core concepts there, and then just very few conventions for success. I think will be fairly familiar to the folks here who are dealing with Apex. Record trigger flow is this nice little thing that you see when you go to build a flow in the new flow window. And as you can see, the description here launches when records created, updated, or deleted. That part for me is pretty key. As we all know, like for a long time, Salesforce has had a lot of power built into Apex. Some parts of it, such as deletions, are only accessible through Apex, but record triggers flows changes that. So comparison of Salesforce automation is probably necessary. We can start with the oldest and the longest living, which is workflow rules. Declarative feature, we all know and love, handles only create and update operations, and it doesn't traverse object relationships very well. So I think most of us are familiar with the limitations there. You can basically do operations on the current record, some operations on a parent record if you're going through a master detail relationship, are really pretty limited in terms of the capability for updating records and reading information from related things. Next iteration of this was really Process Builder. Process Builder gave us the ability to have another declarative feature, which similarly only handles create and update operations. But the cool thing about Process Builder is it gives more flexibility into traversing lookup and master detail fields. And the coolest part of this is that things that you can't do in Process Builder, you can have the option to extend with Apex. Record trigger flows are the next evolution. I mean, under the hood, I think we probably all know that Process Builder is a flow. Record trigger flows are obviously flows. So I think a lot of things that Brock talked about with, working with flows will apply very well to record trigger flows. And the main difference here is that it handles delete operations, which basically gives you full control over DML lifecycle for a record. It's able to traverse lookup and master detail relationships. It supports looping and more conditional branching that the Process Builder doesn't, because it's more of a full grid type of layout. You can draw a graph with if then and loops fully in there. So more complex logic can be implemented with record trigger flows that function more like Apex. And for things that the flow doesn't do, you are still able to extend it with Apex. So fairly flexible, fairly powerful. And obviously at the very end of the day, we got Apex triggers. Only downside being that you have to know how to code, but you can basically do whatever you want to your heart's content. Rest of this Prezo is going to be focused mostly on the record trigger flows part, just to see what some of the cool things about it. This is just a walkthrough of how you get there. Flows, go here, you click new flow, takes you through, click this record trigger flow piece, go to create. And now it kicks you over to basically selecting a start. You pick an object, you pick the trigger. This is very similar to Apex when we said define the trigger on an object and define the context where it executes. And then you can pick entry conditions. So the rest of it starts to feel more like workflow rules or process builder. And again, this is a key part. The options that are available here give it much more parity with Apex. Once you get into it, it really is just a sequence of steps. So very script-like. You start from the very top, start, you've got the end element, and in between, you're just adding elements, building blocks, very visual way. I mean, you're familiar with flows, and you're basically building out the step-by-step logic, updating records, making decisions, doing loops, performing other actions along the way. So the rest of this is standard flow interface. Now, what's really cool about the record trigger flow here is it gives us declarative control over a couple of things that historically has been difficult. One is you can run things immediately, and you can also tell it to run things asynchronously just by design. It tells you to do that. But beyond this, in the same flow, you can also have branches to run things on additional scheduled paths. So you can have some things that run immediately, some things that run asynchronously, and you can have some things that run 2 hours from when the record was last updated, or some things that run like a day after the notification date or any other custom field that you might have. So you've got a lot of good options for managing the logic within a single piece of automation or declarative automation. So really the point is that declarative developers are now just drunk with power. It's quite awesome. Now, if you're going from workflow rules over to this world of record trigger flows, it's pretty straightforward. Here's a workflow rule. And there are lots of equivalent concepts. You'll find basically record trigger flows are able to capture everything that workflow rules do. You can capture things when it's created. Record trigger flows do the same thing. And you can handle things on create and update. You can handle things on create and transitioning to a condition. So this prevents us from executing logic that is duplicative, such as assigning account owners or changing rotating records. You can also set entry conditions. You can create records. You can update records. This part, obviously, you can do it on the record that triggered the flow, or you can update related records as well, which is very powerful. And send email alerts. And also, this part was kind of neat for me. I think it might have been around for a while, but you can send outbound messages. This uses the same outbound message component or the field outbound message workflow component. So everything that's built there is reusable in the record trigger flow. And to help people drive adoption here, there actually is a tool officially from Salesforce currently in beta that allows you to migrate to flow. So you basically select the thing, you hit the buttons, you go through the process, and Salesforce will do its best to get you out of the workflow rule world into the new world. So pretty nifty, hopefully it drives adoption. One thing I don't think I mentioned, which I will get to in a little bit, is in the workflow triggers and workflow order of operations, when workflow rules perform a field update, that kicks off a second execution of all of the Apex triggers. And if your Apex triggers are the bulk of your system processing time, that doubles your processing time, or potentially even more. So the benefit of doing the way that the record trigger flow does it is like this is actually happening before the record is locked. So it functions the same as a before insert, before update operation in Apex. That means you don't get the recursive behavior that you get with workflow rules, and you save a lot on performance. I think that's really, worth calling out to this developer crew as you're thinking about improving the performance of various objects. So if you're going from process builder, that's very similar. Here's a reminder of what a process builder looks like. And there are also full equivalents for everything that process builder does in the flow equivalent. So you can handle platform event messages. You can invoke the flow from another flow. You can do it when the record's created, when it's created or edited. You have criteria. All the actions that you had, Apex, creating records, sending email alerts, calling other flows, posting a chatter, calling other processes, which I guess, processes going away would leave us just with subflows. You can call quick actions, create quick documents, call other flows. I think I might have made a typo here, but basically the short takeaway is that everything Process Builder can do, Flow, the record trigger Flow can do the same, if not better. And while there's no Salesforce tool that does this for you, there is a community tool from unofficial Sales SF that helps you to convert this. I'm not going to play this video, but I just wanted to share the fact that this tool exists. So if you are looking to move Process Builders over to Flow, under the hood, it's largely the same. So some kind of people out there have built a tool to help you get over a Process Builder into the new world. No, we're going to pause that. All right. And so last thing I'm going to leave you with is, with this new power, just trying to use it responsibly. My suggestion is basically, as you're looking to build it out, adopt the same convention that we have for triggers, like limit your use to just setting up one per context. You can't quite do the same idea of like having a single trigger that handles every, that runs all of the master logic. You do have to break it out into before, after create, before, after update. And there's no after delete here in the record trigger Flow world. You just have before delete. And so here's a suggested naming convention. So it helps you get started without having to overthink how to create these flows. And this is an example. These are some things you might do in the different contexts. Like if you have a flow or flows on the account object, before the account's created, you might want to set an account region. There's a field update, again, doesn't trigger recursive trigger processing, which is nice. After this created, you might request third-party data enrichment from ZoomInfo or Clearbit or something similar. Before an update, you might choose to enforce formatting of the account name. After an update, if the account owner changes, you might transfer some open opportunities. And if you're trying to audit deletions, you might have a before delete trigger that logs the deletion of the account. It ends up creating a separate record out of this. So these are some suggested use cases you have for each of these various contexts. And really, the takeaway here, call to action, is if you want performance out of your system, get rid of some workflow rules, get rid of Process Builder. You'll save a lot of recursive Apex processing time, and record trigger flows are your friends. So if you haven't done already, go ahead and try it out in Flow Builder, and happy to take any questions if you have any. But this is a pretty exciting tool.
Question about sort of the structure you do record trigger flows. Sometimes I see people do a whole bunch of record trigger flows on a single object. Do you feel the architecture-wise, it's better to have a single flow that just kind of incorporate or kind of call upon subflows, but you only have essentially just kind of one main flow runs off an object, similar to sort of one trigger per object kind of principle?
I think the one trigger per object principle does apply. I think it depends on how you look at it. My view is that with a team of multiple developers, having a single point of entry allows us to all view the same set of logic. But really, I think where initially it was like for me when I was bought into the idea of having just a single trigger was because you have explicit control over the order of operations. Mm-hmm. And you have that as well with the record trigger flow if you do stick to just one flow. So I think it gives people visibility. You don't have rogue processes. I mean, if you work in an org with other people, everyone knows that there's very rarely a standard naming convention. But if you have just one flow, it doesn't matter what there's pretty explicit suggested naming here. So
yeah,
so it should be self-explanatory what these things are doing. Again, it's like minimize is I can tell you, like, looking at our workflow rules is a massive headache. It's just bazillion workflow rules named all sorts of things. So trying to troubleshoot that is kind of difficult.
Yeah. Well, yeah, there's other evils about workflow rules, but
yeah,
definitely the future.
Nikita said, any best practices to migrate? I think the question was like, do you choose to migrate to flows or Apex? I don't think there's a best practice. This probably varies by team. So the reason why workflow rules and process builders exist is most likely because you had a team or you're on a team where some people code very well and others prefer gravitate toward the declarative things. And most likely you're going to continue to inhabit a world like that. There may be an org where that's like fully banned declarative automation. That would
That's
make
where
for
we're
an-
headed, I tell you.
Sorry.
That's kind of where we're headed is, yeah, just don't.
It is. It's very interesting. I heard one of my teammates came from a company that I think was going that way. Ironically, I think because they had like a Salesforce program architect tell them that they had to move away from the declarative automation for performance reasons. But Brock, I'm curious, like, what is sorry, not Brock, Brooks, what was your reason for doing that?
I mean, so I'm going to say the challenges I've always had, I think from a design is, I guess I tend to be more of a believer that for every S object in your domain, it's either managed with some sort of declarative automation or Apex, but never both. I mean, as soon as both start happening, that's where because the declarative stuff runs at a different point in the order of execution. And like, I've never seen where eventually we did live to regret that. I tried to do it Mark Benioff's way, and I did a invocable Apex, and now we got to refactor the whole thing. So, I mean, I guess I'm like, it's fine, but it should be one or the other. I think one of the things where I kind of am down on flows a little bit is their lack. I mean, you can do integration tests, but you can't unit test them. Is also another challenge I have.
I think it's the unit testing piece. I actually don't know if this applies to flows, but there was a change last year, 2 years ago, where process builders had a requirement for coverage. Like, it was very light coverage. You just had to make sure the thing ran.
Yeah.
You can get coverage, and I've written unit tests for process builders and things, but I guess, I guess I feel like as a developer, probably one of the best things I've done for my flow in the last year in terms of writing quality code was switching to TDD. But you know what I mean? That means you're writing these really small atomic tests with these little tiny methods most days. And you can't do that with the declarative stuff. You really have to, hey, when I have a contact, an account, and an opportunity, and all these things are set up, and I change the opportunity, which not taking away, integration tests are still really important, but anything where I can't unit test, I'm skeptical of.
Yeah, I remember seeing sort of semi-official, I guess, a best practice guide. I think it's either the dev blog or architect blog. What they said is essentially what you just described, Brooks, is they didn't advocate for either Flow or Apex as sort of superior, but they did say pretty explicitly that you probably should stick to one when you're automating an object and not mix the two. That's what makes it harder to manage the mixing of the two. So I think there is a lot of truth to that, and what you explained and the other factors. So that might be at least something a lot of people can agree on. To get people to agree on which one is better is a much harder task.
I think at Drift, for the foreseeable future, we'll probably still have a mixed world. I mean, it's more it's like, I think it depends on what the company requirements and the culture is, because we generally try to move responsibility for development closest to the people who are doing the work. And so that means outside of my team, there are the various operations departments like marketing ops, sales ops, customer ops. They're all fully equipped. They're all admins to be able to build out their own automation. And they're very capable people, like they're very logical thinkers, just they don't dabble in code because there is a learning curve to just get over the first hump. But they build very reliable things that for what they need to do. And also couples, there's an in-between step as well for us because we have our integration platform. So we use Trade.io, and that allows for an additional level of technical automation, so you can do things across objects, like do scripts and do other things with this graphical automation tool. So I think it would be, I guess, like in our company, it would be tough to get to a point where we could choose, like we would enforce Apex or declarative on any particular object, just because there are a lot of cooks in the kitchen, but it enables us to do more, I think, at the end of the day.
Right. Yes, that's a very practical challenge. And yeah, occasionally when we were working for a particular client, they're pretty green. So we also try to help them to set up governance in terms of how they choose a certain architectural pattern. And yeah, this is usually the moment you kind of have this kind of conversation to say, do you try to at least nudge your team to do a certain way. So yeah, if you never sort of try to do that from the beginning, and once the system is laid out and get used by many teams, and it's definitely getting much harder to do that. But either way, I think it's a great conversation to have, to just kind of constantly look at the pros and cons. That's pretty important. Yeah, for me personally, I lean Apex a little more recently, mostly for the reason that that's just a type of easier to manage source code. Flow is XML, so it's just inherently more hairy to wrestle in your CI.
Merge conflicts in a flow are always fun.
Yeah,
That is a good point. I 100% plus one Apex for ease of code reviews.
Right. Yeah, and yeah, I think if you have to work flow a lot, then they definitely need the sort of magic tricks Brock was demonstrating. It's essential to have those things.
Very cool. Thanks for having me, Bing.
Sure. Thank you so much, Marty and Brock and Brooks. This is fantastic. I definitely enjoyed this. So yeah, we're at the end. Again, this is kind of format we're gonna continue to do for a little while. So what I'm gonna do is probably just kind of start almost like a sign up sheet for the next meetup. So I definitely want to encourage everybody to think about some of the things you want to share. Definitely don't feel like you have to have something great to say, and anything you feel interesting, or sometimes then you don't even necessarily need to have a definitive answer to certain things. If it's a question or something you want to discuss, you can present that and just within the group, like the conversation we just had. We don't necessarily reach a firm conclusion, but just the discussion itself is really helpful. I always feel that way. This kind of question and try to answer things, that this is where ideas come out, and we learn something to do things better and keep improving. So, all right, great. Want to thank everybody joining again, and have a great evening. And I hope to see all of you again pretty soon.
Everybody.
Have a good night, everyone.
Thanks, Ben.
Yep.
Good night, everyone.
Bye-bye.
All right.